I'm going to give a seminar on AI in robotics, from image interpretation to intelligent action. So when I say this topic, you can see I'm saying about robot. So we have seen so many robotic movies nowadays, many animated movies based on robots. And I'm going to say what is AI in robot. So we also have seen many robots we use in day-to-day life, like to clean the house, to serve foods in restaurants, and so many. So what is special in AI in robot? So when a robot makes a decision by its own, and by seeing the image or by seeing some action in front of it, how does it react? So we say that as in artificial intelligence in robot. So this topic is apart from whatever equality, inclusion, or but this is about AI in robotics, and I tried to make it much more simple, from different from what I have done in the PhD or something. So this is not fully about surgery or medical terms. This is about how does the robot react to a particular object in front of it, or a particular tissue and seen in an image, that's a medical image or something. So this is what I'm going to say about today. And these are the contents of my slide. You can see I have said what is robot. We all know what is a robot, but I'll just say a few points on that, and then introduce some key technologies, what the robot follows, and then a simple block, and then some conclusions. Here is the first slide. What is a robot? Robot is nothing but a machine which is going to do its tasks automatically. But the main thing is that it has to be pre-programmed to do some intelligent action by itself. So it does 4 different tasks. The first task it does is start learning. So before all these tasks, the robot is pre-programmed with the AI or machine learning algorithms, and so many pre-programmed algorithms. So it is not just to go and do it directly. We have to train the robot before doing these tasks. So first the robot is trained, and then when the robot comes into life, it has to learn what it sees, and it has to reason what it has learned already. Meaning that if I'm showing a banana, it has to a rotten banana. Suppose it has been trained with a normal banana, but it sees a rotten banana, then it has to reason out whether this is a banana or not. So reasoning, and then problem solving, and then making a decision whether this is a banana or not. So this is a simple example I've given. So these are the steps how the robot makes a decision from what it has seen. So why AI driven robot in surgery? I have moved into surgery, but not much more deep, just seeing the image. So why this kind of robot is used in surgery? Because it improves visualization and localization. So whenever an image we see, a surgeon sees, he can just see the 2-dimensional view of the image. That is only the front portion of the image. And he or she cannot localize where the particular image is located on the body, or he suffers from making a decision of what he sees. So this kind of robot can take the image into it. It can visualize it 3-dimensionally, and it can localize where the particular object is present in the body. So simply to say, it can take the image of anything what it has seen in its front, and then it can visualize it in all dimensions, and it can localize. The application might be different, not only surgery. There might be a military application or any other applications. So it can make 3-dimensional views. And also it can make minimal invasive surgery. It means that a surgeon putting a cut on a body is much more deep. Whenever the robot makes a surgery, it can calculate how much millimeters it has to put the cut dissection line on the body, and the outer wound will be lesser than a surgeon make. So this kind of surgery or robot is very much used or developing these days. So the requirements of this robot to do the surgery or to do such action is 3 branches of artificial intelligence. The first branch, we say it as the computer vision. The computer vision is that the robot's eyes. The robot eye is not a normal eye, it is just a camera. A high defined camera, and then getting the vision, getting the input, what it sees from the video or what it sees from the picture kept in front of the robot, and then learn pixel by pixel of the image. So that we say it as machine learning. So I have already said the robot is being pre-programmed with many different algorithms. So it just tries to learn what it sees and compares with what it has learned already. So it does some identifying patterns kind of algorithms. And then this machine learning might not be sufficient for this surgery cases or much more different applications. We need deep learning. Deep learning is something much more complex, because when we go for brain tumor surgery and such things, the deep learning becomes complex. The robot's intelligent actions becomes complex. We need deep learning. So here we can say another deep learning. I can say natural language processing is one of the deep learning. So what does that means? The surgeon can speak in his own language to the robot about the surgery or how the surgery can be progressed, and what decision they can make, and he can discuss, and the robot can make a note out of the keywords what the surgeon is speaking. So that also comes under deep learning. So these are the three branches a robot requires to do a surgery or to do an intelligent action. And there are so many subtopics under this artificial intelligence, where we choose only these three for this particular robot: machine learning, computer vision, and natural language processing. The first two is being already in progress, but in working. The third, natural language processing, is in progress. So that kind of robot is developing. And this is a simple block to make you all understand what I'm going to say, not a surgery-based example. So consider I'm going to order a robot to pick the banana from the table. So I have to first pre-program how the banana looks like using many algorithms. So how I will program is that I can program the robot with the shape of the banana, the color of the banana, the texture of the banana, and so on. So I just program it with some texts and datas, features of this banana. And then I'm asking the robot to go and pick the banana. It takes a picture of that particular table. And then the picture is generally to be pre-processed to remove the noise out of the image, because the noise, always there will be noise in the image. This is a mandatory step for all image processing algorithms. And then this robot picks out the particular object, the region of interest. So all items on the table will be segmented like this. So it takes the banana out, the apple out, or any other object, separates all these objects. And then it learns the features of all these items. The features I said, the texture, the color, the shape, and these are the textures of these fruits. It learns all the features of these fruits. And then it knows how the banana looks like, because I have classification. There are two steps in this classification. One, I say the training, the other one is testing. The robot is being trained first with the banana's features. And then this is the testing procedure. I'm giving a banana's features inside. So the robot already knows how the banana look like. So it compares and it goes and selects this object as a banana. So this is a simple block I have said. I'm just going to replace this picture with the MRI image picture on the next block. This is the actual block I did worked on this. So this image is being replaced with the brain tumor image picked from the MRI scanning scanner. And there will be 64 slices of head images like this. So the eyes of the robot will not get captured this MRI directly. This image is fed into the robot from the MRI scanner, and then this is pre-processed to remove noise. And we segment only this tumor part. That means the region of interest is being picked separately, what I said before. And then the feature of this tumor is extracted. Now, what are the features? We can say like the intensity of the pixel or the texture of the pixel. These comes under these features. I take so many features, kurtosis, skewness, and so many features are there. I take these features out, and I have already trained the tumor with such kinds of features. This classification will classify whether the obtained tumor is obtained pixel is a tumor or not. So it will classify, and then we get the best out of the solution, and then I try to three-dimensionally reconstruct the total tumor to get a three-dimensional view. So there are 64 such slices. So all 64 slices will be image segmented, feature extracted, and we get only the tumor part out of all 64 whole head images. And I get 64 slices of such tumor out of a head, and all are stacked together to get the three-dimensional reconstruction. So this is how the intelligent robot works. And this is a simple, I'm just crossing my, yeah, I'm just going to finish my presentation. So here I've shown this because this is a full brain structure, and a minute part of this brain is being enlarged here. You can see this minute part has so many cells like this, and the cell called green color is called astrocyte, and this kind of white color cell we say it as oligodendrocyte. And if the tumor arises in this part, we say it as astrocytoma. And there are so many different types of tumor, so it is very complex to do a brain surgery. So to show that, I've shown this image, and these are all the robots. These are all the example of robots which is used nowadays. ROSA robot used for surgical guidance. NeuroArm robot is used for MRI guidance. These are all the names of the robot which is used nowadays in surgery. And that's my presentation. And these are all the techniques I used for pre-processing, Gaussian filtering. And after pre-processing, after removing the noise, my image will look like this. This is the input, and this is the output. So you can see the difference between these two. There will be minute detail difference. And then these are all the segmentation methods. I can choose any of these segmentation methods, algorithms to train the robot. And the output, when I segment, I'll get this tumor part alone. From this total tumor section, I get only this tumor part. And these are all different views of the tumor. So just to see and know how the tumor segmentation works. And then I three-dimensionally reconstruct the whole tumor part using fast shear warp volume rendering algorithm. This is the name of algorithm what we use for three-dimensional reconstruction. And that's it. The conclusion I say is that nowadays the tumor surgery is done using the MRI scanned images, but the real-time scanning images is not done directly by the robot. So real-time surgery, during that, the MRI scan process can be updated. So not doing the scanning at that time, but while doing the surgery, another MRI scan can be done to update what it is doing, what kind of surgery it is doing. So that kind of improvement is necessary, and it is under progress and under investigation. So that is a future work we can see on this particular topic. And thank you for the opportunity, and I hope everyone understood what I said. And if there is any question, please, you can shoot on. Thank you.
I'll be talking to us through about enhancing inclusive learning in higher education through AI-powered assistive technologies for students with specific learning difficulties. My contents, I'll be talking about the introduction, looking at the challenge, role of AI in higher education and inclusion, examples of these AI-powered assistive tools, benefits for students, for the actual students, then case study, those considerations, and dining with students and my. As an introduction, AI-powered assistive tools are digital tools such as text-to-speech software that use artificial intelligence to help people overcome learning, communication, or accessibility challenges. In education, because I'm looking at higher education, it supports students specifically with specific learning difficulties, okay, such as dyslexia, which are neurological conditions that affect how a person learns, processes, and understands information. The traditional teaching methods often make learning hard for this set of people, but AI, artificial intelligence, is helping to change that. So the challenge we face, SPLDs affects how students process information. For example, students with dyslexia might struggle with reading and spelling. Okay? Those with dyspraxia might also find planning and writing difficult. Also, ADHD patients affect attention and memory. So higher education often relies, on long tests, lectures, and timed exams, but AI has come into place to help to ameliorate these difficulties. So these methods can exclude or disadvantage neurodivergent students. So this is just a diagram showing us a general view of role of AI in higher education. We can see it's basis personalized learning, okay, and also the students, personalized students, okay, administrative for students, okay, and basically we're talking about students. So it's very important where we use AI for them in higher education. And also when we talk about inclusion, AI offers a new way to make learning more inclusive. Okay, because we're talking about people with special learning disabilities. We're not judging them. Okay, we're trying to bring AI to help them in their learning in higher education. So this will help them learn in ways that suits them best. So they are learning in their own pace. They are learning at their own pace at how they can follow through in higher education. It can also help them to work more independently, where they'll be able to work independently. They don't have to work in groups. They have to work on their own pace, and they also take part more fully in academic life. Okay, they're in schools, they're in universities. Sometimes they might not follow through because of their disabilities, which we understand. So AI helping them to come part or to take part more in academic life. These tools are not just compensatory according to the UNESCO, they are also empowering. Basically empowers them to make sure learning is achieved. So examples of this AI powered assistive tools. Some examples include have the text-to-speech readers, which reads digital text aloud. Okay, for example, for people that are dyslexic, okay, we have speech-to-text tools. This converts spoken words to written text and is very good for students with dyspraxia or ADHD. Then we also have the smart spelling and grammar checkers, like Grammarly. We all know Grammarly, or Microsoft Editor, which helps us to check, our spellings and also for our grammar and offers real-time feedback. And we have the AI learning platforms, which adapt learners to a student's learning style and speed used in Century Tech and Newton. The fifth one is the real-time transcription. For example, like Otter.ai, which provide live captions lectures. Remember that these tools help students learn in their own way at their own pace. So these are some of the examples of AI-powered assistive tools which helps SPLD students. The benefits for students. These tools support reading, writing, and organization. Also focuses their attention, make sure they are focused and also attention. It gives them that confidence and that independence to carry out higher education work. And at the end of the day, they have better academic outcomes. For example, a student using text-to-speech and writing support software improved their essay marks by 15% at a UK university. So they have other activities going. When using these AI tools, they saw that their essay marks were increased by 15%. For example, also, at a UK university, dyslexic students used text-to-speech and AI grammar tools. Also, their essay marks improved by 15% and they felt more confident and independent. This shows that the right tool can unlock the potential. So AI, yes, they are not so dependent on it, but it's very important for them to learn using their teachers, train their teachers, train their lecturers to actually put them through with the specific AI tool they have to use. Some of these important considerations when we're looking at AI tools, we should think about digital literacy. Do students and staff know how to use these tools? Are they trained staff and resources? Are we protecting student data and avoiding bias? So universities must choose tools that are safe, fair, and easy to use. So in as much we want to bring in AI into our higher education, of course, we should make sure these students know how to use these tools. There should be support from our universities, training the staff and giving resources, and also their data should be protected, so we will not breach the UK GDPR rules. So code designing with students. This is just talking about technology. Of course, you're talking about technology. You're not just designing it for them or just for them. You're involving them. Okay, you're making them relevant, putting their voice to actually test these AI tools before, you release the product out. So this encourages student voice and agency. It helps create social just learning environments. And co-design is not just about tech, about respect and inclusion. So you're including them in what you want to design, what you want to test, and for them to actually use it at the end of the day. As a point of conclusion, SPLDs affect learning but not ability. Okay? AI tools help close this attainment gap. So with proper support, the main thing there is support. Supports these special students to actually have these AI tools and for them to use them. Okay? Students learn with confidence, and also ethical use and co-design are really essential for long-term success. So at the end of the day, we should try as much as possible to actually help them, to support them to use AI. I'm from the Department of Health and Social Care, Public Health. That's my main background. Yeah, we use AI because there's actually a relationship with it, because when we're talking about data analysis, research, we use a lot of AI tools. Of course, we're not dependent on AI tools, but still it's still related to our department, so we can't shy away from it. AI is such a growing field where people are trying to make their voice and put their voice in it. So at the end of the day, we as scholars, as teachers, as guardians, we should help SPLDs to actually create AI tools for their higher education. AI, when used thoughtfully, can truly level playing field in higher education. Thank you so much for listening. This is my references, the video for us to watch later at the end. Thank you for listening.
Robot Day is a celebration of science, technology, engineering, arts, and mathematics. We're an event series that aims to inspire, educate, and inform people of all ages about robotics, automation, and AI. Our key events typically last for a day, and we have one in Coventry each year, the last 2 years, and we're looking to build a new event in Nottingham. To give you an idea of what the event looks like, I'm just going to play a short video. But first of all, I will show you the mission that we're on here with Robot Day, and hopefully get you as inspired as our young dancers in the picture there. So the mission is to show how robotics, automation, and AI can be part of a better world for everybody, and how everybody can include those topics in their world. There's a lot of disinformation, a lot of nervousness around the topics of robotics, automation, and AI, and we're here to say these can be a force for good in the world, but there's some difficult conversations, and let's have those together in an engaging way where people can really get hands-on and experience what robots do for themselves. We're hoping to grow as an organisation. Currently, we're based in the UK Midlands, but with the right support and the right people and the right sponsors, then we hope we can grow much bigger. So here's that video I promised. If I can get it. There we go. Right, so this is a video of our event at Coventry College about this time last year. We're hoping to be back at Coventry College in the autumn. Here you can see all the visitors having lots of fun and getting hands-on with those robots as we discussed. You can drive a robot, you can build a robot, you can program a robot, you can talk to people who build robots for a living, you can hear inspiring talks about engineering, how to get into engineering careers, discuss all those things with the people who do those every day of their lives. We hold the events so that they're accessible to as many people as possible, typically in the city centre, close to public transport, and also to increase the accessibility and diversity of the events. We typically hold them in locations where there's high areas of deprivation, where people don't necessarily have the opportunities to attend events like Robot Day in their community very often. So the principles that we've built on originally came from the Institution of Engineering and Technology. So sorry. Very nice to be invited today to talk to an IET audience, and the IET was there at the beginning and continues to support us through funding. So we've adopted the IET's mission of engineering a better world, and we remain to this day volunteer-led and volunteer-run. Our events are delivered in collaboration. We partner with venues such as Coventry College, Nottingham University, and Quad in Derby. We partner with professional institutions, the IET, of course, IMechE, and several others. Academia, we have a lot of links into academia through my own research and through the support of those universities attending our events. Similarly with industry, we have a lot of industrial robotics companies support our events and offer opportunities to the learners that we engage with. We reach out to schools, but wider than schools, we're a community organisation that engages audience of all ages. And our events are free at the point of entry, and we're very keen on putting the arts into STEM and making that about science, technology, engineering, arts, and mathematics. Creativity is absolutely central to what engineers do, and engineering inspires creativity, and the two just go naturally together, and you can't really have one without the other. So that's why we're very keen to have the A in STEAM. We're not for profit. Every penny that we receive goes towards delivering events. As I said, we were founded as a group of IET volunteers. We've now expanded and have volunteers from other organisations and our own separate organisation, now funded in part by the IET. So these are the pillars of the IET that we use to establish our way of working. You can see integrity, excellence, and teamwork at the bottom there. But the strategic priorities that we have still align very well with those of the institution. In particular, we're demonstrating public relevance of what the topics we're talking about, but also the relevance to the public of institutions. We definitely work across boundaries for impact, and we engage with a lot of people, helping them deliver professional development, whether that's through actively running activities. We've done CNC upskilling, for example, this year for a group of adult learners through Coventry College. But also there's a lot of opportunities for engineers to get involved and use Robot Day as a CPD activity. So I mentioned we get involved in some other types of projects, not just delivering one-day big events like you saw in the video. A particularly impactful one of those was the Inspiration Rover project, which was run by a group of Derby University students about 5 years ago. They built this incredible rover based off some plans that are freely available on the internet from NASA JPL. If you'd like to know more about that, I highly recommend the video. But this was a joint project, and this is, I think, one of the key messages I want to get across tonight is working together makes things better, and pooling the resources and the skills of different organisations enables us to deliver impactful events and programmes that we couldn't do on our own. In this case, we targeted through the Derbyshire Education Improvement Service a group of students, 12 students who had been excluded from mainstream education or who were at risk of being excluded. A number of those were students who engaged with the project were taken off the at-risk list, and we even had one student who was fully excluded from mainstream education who re-entered mainstream education as a direct result of engaging in this project. So yeah, robots and automation and AI can be lots of fun, but they can also be a real vehicle for changing lives. And that it's not just about changing the life for that young person, but it's also about changing the lives of all the young people, because if we can use those resources, that is very expensive to have children who are not in mainstream education, and if we can keep those children in mainstream education, that means that there's better resources and better quality of education for everybody. So yeah, the students who took part in this were absolutely incredibly lucky to get invited to a celebration day at the National Space Centre, and they even got to meet someone who'd been on a reality show from the TV, the BBC show about choosing Britain's next astronaut. So like, through Robot Day and through collaborations, we can create incredible opportunities that really do change lives. Other projects that we've been involved in outside of the one-off event days, we run school learning days for over 200 students. We've funded and supported a project called Dance Like a Robot, which features regularly at our events now. We've run poster competitions for schools to design a robot for a better world, and this year we held our first university robot race with Coventry University students, which we're hoping to expand to other universities in future years. So our key message is to showcase the value of robotics, automation, and AI in society, raise awareness of and engagement with issues around those topics, focus on the interplay between the science, technology, engineering, and maths with the arts, and educate and inspire and inform people of all ages. We do that in a way that promotes diversity and inclusion, and particularly focused on addressing skill shortages. And to do that, we work with expert local and international partners to increase public participation. Finally, just a call to action for yourselves. If you like what we do and you would like to help, there's lots of ways you can get involved. First way is to visit that link or scan the QR code, and there's a lot of ways you can help. You can join the committee. Currently, we're looking for people to help with managing events, help with working as a treasurer, and also with marketing and social media in particular. But if you've got other skills that you would like to offer, then we're very glad to hear from you. Of course, you can also help us by funding an event. We're always keen to hear from sponsors, and without sponsors, we simply can't do what we do. Or you can come along and volunteer on the day and be part of the vibrant, exciting, engaging, inspiring buzz that is a full robot day. And you can do that by bringing along an exhibit, bringing along yourself as a volunteer, providing a talk, or running a workshop. And if you like all of that, you'd like to get involved at an organisation level, then we'd love to hear from you. Work with us to improve educational outcomes, engage communities, foster partnerships, raise awareness. And I'm sure there's something that we're not doing that would be amazing. So if you know what that is, then please tell us. Thank you.
The presentation, medical telemetry for drivers fatigue monitoring based on Bluetooth technology. I'm lecturing Coventry University. I'm working from year 2000, and I give a final year project to undergrad, postgraduate students based on tasks which are required for education and for industry. And several projects, I just want to demonstrate what our students designed, fully working devices. One of this project for monitoring fatigue. We designed it to monitor fatigue of driver. Of course, there are such devices on modern cars using video cameras, but video cameras have some disadvantages in different driving conditions, environmental conditions. They provide sometimes good results, sometimes not good results. We are using completely different idea. That's why I suppose it would be interesting. We presented this in a hospital, Coventry Hospital, and doctors said, yes, actually, this is a very interesting idea which can be considered for hospitals as well. What we are doing is we are designing a system to monitor driver tiredness, but it can be used also to monitor tiredness of a person in wheelchair, for example, disabled people using this technique. Well-known ECG system is used very often, but we are using a different type. What we are doing, we are measuring potentials, electrical voltage when a person is blinking. It can be measured remotely using sensitive sensors. And according to medical research, I discussed it with doctors in hospital. If, for example, a driver is blinking more than 60 times per minute, it means he's tired. So we can measure such a level of potentials or impulses, count these impulses. You can see on this slide we took from a real measurement. If it exceeds 30 times per minute, it means we can make a conclusion, yes, this person actually is tired, and we can give warning to the driver, for example, to reduce speed or even to stop vehicle. Or even we can send such a warning remotely via mobile phone network to GP of a person. You can see all schematic medical sensors which detect voltage potentials. We are using some microprocessor from microchip company, and using Bluetooth communication, data is transmitted on PDA, for example, personal digital assistant or mobile phone. So this is remote monitoring, and also we design software for both, for microprocessor to collect data from sensors, and for PDA or mobile phone to monitor number of such times when driver is blinking. I'm not going deep in electronics, just demonstrate how does it look. This is the microprocessor, and this is the amplifier. The main problem is signals usually very, very tiny, and there is electromagnetic noise, which is called EMC, electromagnetic compatibility problem. This is why we need to design quite sophisticated electronic circuit to get rid of this external noise, to extract only useful signal. This is the program in C programming language for microprocessor to collect data, to count number of impulses. It means how many times the driver is blinking. And the second problem using Visual Basic for visualization. Because we need to present these results to doctor in graphical form or in the form, you can see numerical data. And this is the Bluetooth data communication radio transmitter. Receiver already built inside of every mobile phone has a Bluetooth receiver. Of course, we can extend this project. I will demonstrate next project how to send data remotely via mobile phone network that GP can monitor many patients simultaneously, regardless where people are located, using so-called GPRS communication, or nowadays very fast communication. I just want to go to the also second my slide and presentation, which is a continuation of previous. How to transmit this data remotely. This is another project. We are designing a system based on mobile phone for data monitoring anywhere in the world and anytime. This is all block diagram, medical telemetry system. There are such devices on the market, but they're not specialized. They are just for general application. Our advantage, we can adjust to particular task from a hospital or for people with some disability problems. And data transmitted anywhere in the world, even person is located in another country, for example. And in this particular case, we are monitoring ECG. In first case, we monitored blinking. In this case, we are monitoring ECG. This is very important if people have problems with heart. The GP will have all this information in the real time. If he will see that some parameters exceed predefined level, he can contact directly by mobile phone that patient, set him, for example, to stop vehicle, to take a rest, or even just to go straight to the hospital. So this is all schematic how data transmitted using GPRS to internet and to medical center. The same problem, we need to deal with electromagnetic interference. Always there are devices which interfere electromagnetic noise. This is why most work actually concentrated on designing of special filters, low-pass filters. You can see in order to monitor, usually 3 sensors are attached. And you can monitor on the computer screen, but data transmitted remotely via internet. And third project I want just to show is which is directly related for problem of people with disabilities, for example, in wheelchair. it is sometimes quite difficult to control external devices, for example, switch lights in the room, or to control robots if students are doing practical exercises in the laboratory in university for people who in wheelchair. In this case, we suggest to use voice control. So we are designing such electronic schematic in order to control by voice. So person doesn't need to touch by hands. He can record commands. These commands are kept in the memory of this voice control system. When he will pronounce this command next time, automatically a signal will be generated on the particular pin of this device, and depending how this pin is connected, we can control electric motors. For example, you can see in the end schematic to control electric motor to rotate clockwise, to rotate anti-clockwise. If you can control one simple electric device like this electric motor, it means it's just possible to control any electronic devices. Robots are based on motors. For example, there are 6 joints and there are motors. So in this case, a person can control a robot, each joint individually, using voice. I'm not going in schematic, but people who are working with electronics can understand how it works. Each bridge, when we apply a signal on A and B, the current flows through transistor. In this case, transistor is open, and the power goes to the motor. The second transistor, Q4, opens, and power goes to the ground. It means close the loop circuit, voltage flows, motor is rotating. No, of course, it would be nice to connect several such systems together. This is perhaps would be interesting for other students' projects.